This is a loosely coupled show with James Hickey and Comartin. We talk about software architecture and design. Make sure to subscribe to get all our latest episodes. Yeah, so caching, it was top of mind, and I know like we talked about it a little bit before in an app that you were dealing with a few months ago. You were talking about it, and then it just came up with something that I was dealing with. So I created a video around it, and I tweeted this saying that like pro tip is caching, don't. And like I'm kind of being a jerk. It's kind of like a jerk statement because it's like, yeah, I mean, I cache stuff, so it's like I'm not even following my own rule. But the point of it really was that it's not as simple as just, hey, let's throw Redis in the mix here and all our problems are solved. It's like you're solving a problem, but you're going to add a pile of complexity that I don't know that if you never really dealt with caching that much, that there's a bunch of little caveats that I only kind of talked about a few of them because I like having my videos super long because people just kind of bail out. Yeah. But it was a few things. One was like, it's the old, you know what I mean? What's the complex things in software? It's like cache invalidation. And that one is and isn't to me, surprisingly. Like I've never really had that big of an issue invalidating cache. I assume the reason why cache invalidation could be a real pain in the ass for people is because they don't have a centralized place that is making those changes to your primary database.
Right? I would add another one.
Okay.
I don't want to break your train of thought though.
Okay, so I was going to say like that. And what I meant by that is like our rule is, okay, there's a specific API generally, whether people know this is the rule or not, but there's a specific API generally that is making state changes for something. If you want to know where data changed from, you're going to go to those features or that section of the system that deals with that. If there's no random store procedure somewhere, there's no some other app somewhere else that's has access to the database. Hence why the whole services don't interact with other services databases. Like there's a centralized place where state change happens to our primary database. So therefore invalidating the cache is actually really easy because there's only one central point where stuff gets changed. But if you have other apps or multiple apps or store procedures or God knows where that are changing data, I could see how, well, cache invalidation would be a nightmare because how the hell do you invalidate the cache if you got stuff, like you got no centralized place to know that it's happening?
Yeah. That's basically, I was going to kind of highlight that and actually come back to the whole boundaries thing again, which it keeps coming up. If your boundaries are wrong, and we've talked about this and kind of, I guess, which will be an episode on its own with the cap and all that stuff. It's like if I am performing some kind of command or action or some kind of query or whatever it may be, and then if my boundaries are wrong, then in order, this comes back to that whole like consistency thing. If actually the thing that I'm dealing with, I've actually modeled that wrong and I've split it incorrectly, and now like, let's say I split it apart into two, and I have one part of that in one system and one part of it in another system, or not even system, it could just be in another part of my application altogether, like in the same code base. But then it's like, the part A always needs part B, and then maybe even like the other way around. Part B sometimes needs to know things about part A, which like clearly they probably belong together if that's happening. But then you get those kinds of things where it's like, that's two, but what if it's like five, right? What if it's like five different parts and they all...
Oh, I see what you mean. Like you
really need to have information from the other parts. And it's like, it's like in part A, it needs to know when it stores its information, it needs to actually invalidate like pieces of the
I
other
see.
things,
Yeah. So you're
right?
like,
And
it's like this composition thing where you have some
exactly,
cache.
yeah.
Yeah. I don't know if I mentioned that in my post, but maybe somebody left a comment, which I was kind of touching on, which is, yeah, if you have like something in cache being composed from a bunch of different things, then yeah, that would
Yeah.
be problematic as well. However,
But,
if you're
but you may
using,
not like totally realize because
oh, I
your
see what you
boundaries
mean.
are wrong, right?
Yeah.
It's it's like I can't think of it like an actual example, but I've seen it. And it's basically, yeah, it's like you said, right? It's like it very much comes down to just that lack of thinking about designing boundaries right. So it's like you said, you have a stored procedure that's selecting like information from just all this stuff, or like people. I mean, we use stored procedures to query and do commands, right? So it's like you have a stored procedure that's like fetching all this data and then storing a piece of that, but then somewhere in your application, like it needs to have some of that invalidated. So yeah, it becomes this like garbled mess of like yeah, some one piece of the application needing to invalidate the cache of like in some cases I've seen like other like remote systems cache.
Yeah. So like, yeah, I understand that. I guess
Yeah.
on how I use it, it hasn't really been an issue, but yeah, once you're starting to talk about this, I'm like, oh, good Lord. Like, like I could see
Yeah.
how that's a problem. For sure.
Yep.
Especially like in older, like systems that have been living a while and yeah,
What's it?
mutated over time. The other thing that I kind of touched on, which it's just that there's different ways that you can deal with the cache or populating the cache, right? Like you can do write throughs where immediately when but again, this depends on what you're caching and how, if that's composed from one thing or many things. But just the idea of, okay, if you're making state change, then to the primary database, you'll immediately add, like if you're adding something to your database, then you'll immediately add that cache value to your cache. If you're changing something, then you'll just basically either update the cache or just invalidate the cache. And then if you're invalidating the cache and you don't always have everything in cache, you're basically doing lazy loading, which is called a cache aside, which is you're basically populating the cache when something needs, when some client or caller needs something from the cache, you're checking, is it in the cache? If not, then you're basically fetching it out of the database, composing it however the hell you're composing it, and then adding it to the cache. So the interesting thing with that is that once you start doing that, you're like, oh, wow, well, you know what? This is awesome, because if the database goes down, it's like, or like if your cache is unavailable for whatever reason, like this is just going to work, assuming you have the code to deal with exceptions, can't connects, and timeouts and crap. You're like, we'll just go and hit the database. And I experienced this. That's all great and dandy until you realize how many calls you're making to the cache. And now those are all of a sudden they're falling back to the database. And it's like, can the database handle all the load now, or whatever you're failing back on, to the database? It's like, you know what I mean? Like, it was a surprise to me. It's like, well, hang on, what's going on here? And the funny thing with the cache, at least with Redis and .NET anyways, is all my issues with it and using like Stack Exchange Redis, not with Stack Exchange Redis or Redis, it's actually the individual processes or host or whatever they're on being CPU bound and not being able to get the data from Redis or write the data to Redis in whatever the timeout we have set as. So that's almost every issue I've dealt with. For the like there's other stuff, but it's never, I should say, put it this way, it's never actually Redis that's causing an issue. It's always the individual client, like, you know what I mean, that's trying to read or write from Redis. That's always the issue.
Yeah. Is it like deserialization issues? Or
no, it's so basically like
other...
the simplest example is if you, for example, have a like, I don't know, I'll just make up a random number. Say you have like 100 millisecond timeout. So any operation that you request to Redis, you're going to say, okay, it's going to be 100 milliseconds. Otherwise, I'm going to fall back to the data. I'm just going to bail out, and then it's going to look like a cache miss, or it's going to go through the same steps, and then it's going to go hit your database. If you have really high CPU, like say you're just pegged, like you're max 100% CPU for whatever reason.
Oh, like already, yeah.
And you try to make that request to Redis, because you're CPU bound and other stuff's happening, like you're not, it's that operation of, even though Redis can give back to you really quickly, you're still going to be waiting, especially with async. Like that's going to take more than that 100 milliseconds, potentially, say it does, takes longer than the 100 milliseconds. So then you'll get a timeout, and then you'll go hit the database. But like, it's not because Redis was down. It's because you were pegged and you actually couldn't perform that operation quick enough to actually
so it actually
receive the
becomes
data.
Like this vicious cycle of like, now I'm trying to
do more.
Hit the database again. Exactly. I'm doing more work.
Yeah.
So now the next request is going to be even worse. And then
and like everything I'm talking about right now, it's like, it's all this complexity, because you're like, that you're dealing now with, okay, the host of this running process. For now, what's the issue? Like, why is it getting these timeouts? Like, why is it not hitting? Because there's nothing wrong with Redis. And then you're trying to figure all this out. And then you're like, okay, well, what we need to start doing is having some type of limit on the number of failures we can have before we like maybe start throwing some metrics out, or we want to automatically fail back to the database if we're just constantly timing out because something's wrong, clearly.
Yeah.
Right? Because you don't know why you're timing out. Is it Redis? Is it like, you don't necessarily know in code why that is that you're timing out. So where I was getting at with this video is it's not just, hey, let's throw Redis in front of something and start caching something.
Yeah.
It's like you're potentially solving a problem of whatever it is that you, like most times I'd assume people are adding caching to not have to make a database call, because you want to basically remove load from the database. So you're going to basically shift it to something else, but you're introducing another piece of infrastructure, right? In the glorious world of the cloud in AWS with Elasticache, like multi-AZ auto failover, it's like, I don't even need to think about it. So it's not like super complicated, but you still have to deal with that thing not being available, right? So you're having to write code that deals with it. Like, you're going to have to write, because you're hitting a different service now, it's like that code that I said, okay, you got to get from the cache, then you got to deal with cache invalidation like we were talking about. Like, it's not trivial. But I get the sense that like it's like, oh, just add caching. Like, it's so
there's a difference too, I think, between like, I have code that I've written and it performs okay, and I'm going to add caching and now it's really good, as opposed to like thinking about the cache first, right? It's like, oh, I already have a cache, so I'm going to write my code knowing I have the cache.
Yeah.
So I'm going to write crappy queries, essentially, right? Or whatever, right? It's like, oh, it works. I tested it on my machine. It works well. It's using the cache and it's fast. And then something happens and it's like, your horrible query is really not as performant as it should be, and you killed your database or whatever, right? Like, you kind of take it for granted, I guess.
Exactly. Because the one thing that, I would say my motto now would be optimize the shit out of the queries that you're doing. And also pay attention to the queries that you're writing that are not like the queries that you're physically writing in code to your database that are the ones that are building out what you're going to cache. Because if you're using that for a fallback, when the time comes when you actually start falling back, like in mass, because you can't reach the cache or timeouts or whatever the case may be, I'm speaking from personal experience in the last couple of weeks, you want those things to be lightning, because you're going to be adding so many more of those things to your database, or whatever database you're hitting. Even if it's a read replica, you're going to be hammering it now, especially if you use that cache heavily, right? If that's an operation of getting some particular key or set of keys, it's just something that it's not obvious until you deal with the pain of it that you're like, oh, this is an implication that I never really thought of.
Yeah, and I've seen caching try to fix like n+1 problems where, just very simple example, right? It's like you have a loop of objects and each of those was written in a way that it needs to do a database query to get whatever. There's like a user property on that. It may use lazy loading or whatever, right? Doesn't matter. Every time you go and hit the loop, you've got to do at least one database call to get that information. So, I mean, yeah, it like, again, if you're in like horrid legacy code that is hard to change, then it's potentially less, quote, risk to put a cache behind that call. And now your loops are not doing a database call every time. So that is an easy fix, and I say less risky. But then, yeah, you've kind of traded off for a whole other set of issues. And if you go through, like, let's say, a whole bunch of areas and do those kinds of fixes, what happens when the cache is not available, or what happens when, like, for whatever reason, you have a high load, which we haven't talked about. If you do have a high load and you're using, like, in-memory cache, for example, you have a threshold of how big your cache can be. And then you get into a situation where every request coming in is having to pop another item out of the cache. And this kind of is similar to what you were talking about, where you end up with this vicious cycle of one request pops one out of the thing, and then the next request has to pop that one out. And so you end up not even, it's like cache misses all the time because they, probably because you're caching too much. At least that's what I've seen, is you're not caching fine-grained enough. And you just have these like massive composite objects that you're caching. But I mean, those are all like, that's just exactly what you're saying, right? It's not so simple, and it's easy to kind of be enamored with this will fix all my woes. And
yeah, because when you start adding it, it's just like, oh, just cache this, fetch it out of the cache, works. Oh.
Yeah, exactly.
It works. This is fine, right? Like, it's no big deal. I think on the surface, it's easy win, but then the reality will set in a hurry when stuff goes wrong, that there's way more to it than just, I just have Redis and I fetch stuff out of here and it's no big deal. And I think the number of complexities you're adding are at a serious cost. I guess that's the best way to put it. Like, it's just not trivial. Like, I think there's a serious cost to it that I don't know. I always wonder these things. I'm like, is it just me? Like, am I in this weird bubble because I don't hear much about it? Like, do you hear about, like, people talking about, like, yes, you hear about cache invalidation, but, like, do you hear about people talking about, like, the complexities of caching? The one thing I just thought about this. The one thing I never even thought of was how people deal with versioning. And I left that out of my video because I'm like, oh, I'll save that for something else. But, like, you want to change, you know what I mean, the structure of the cache, and there's different ways to version it. So, like, that's another complexity. Like, it's...
Yeah. Like I said, I mean, in my experience, like, most developers I've worked with don't even have... That's, like, not even a tool in their tool belt.
To cache,
And the examples I have seen of people using caching is to fix some of those, like, band-aids, like I've talked about.
Yeah.
Where it's like, you need to probably just, like, redesign what you have. Caching's not really going to do anything. And plus, I think the whole other thing, again, like, it's like it just keeps going, is like caching where you're actually affecting the system. Like, you're doing, like, let's say you have some kind of business invariant that you need to, figure out, am I allowed to do this action? If you have caching involved in that in any way, then you're talking about having stale data. That could be a problem. But then on, like, there's kind of a whole other part, or side of the coin, where I think, at least my first thought is probably it's it's not as bad to have caching, or at least it won't lead to as many bad things happening, is like on a purely like reporting side of things, where these are maybe like reports that whatever, it doesn't matter what kind of report, but it's a report that's not like real time,
Yeah.
right? So it's a report that it's like you go to this page and it's going to show you a report of blah 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 blah, and in quotes, we can, this is up to date as of
Yeah.
10, 15, 20 minutes, right? You have that SLA, which is a whole other topic we haven't talked about, is SLAs too, which caching can help, but it, again, introduces issues. But I think, yeah, like if you have a report and your SLA is X minutes, probably is how up to date this is, then caching's okay. And then that brings up a whole other issue of SLAs, where I think people use caching to help with SLAs, which again runs into all these other issues.
The one thing the one thing you were saying that it made me think of this question that I think of quite often, and I think this is like I like everything, it depends on context. However, I'm just like general thought. So this is a question to you is, and you've probably seen this, is okay, there is my favorite thing in the world, a repository. Hence the sarcasm there if people can't tell. You have a repository, whatever the heck it is, some entity repository that you would see. I'm not advocating this, I'm just saying what I see. And then the general kind of feeling or wording I've seen is, well, you know what I mean, because we have this interface, we can swap out this for the cache repository. Like instead of the product repository or generic repository, another sarcasm, that you then have an implementation that uses a cache. So my question to you is, one, have you seen that?
Yes.
Two,
have I done it? Yes.
Okay, now so here's the thing that I always think about is, as a consumer of that ridiculous repository, do you know, should you know, that you may be getting cached data, or in other words, stale data? And do you know what I mean? Like, or is there an expectation that you're getting 100%, like at the time of that call, you're for sure getting what it was at that moment? I know people are listening to this thinking, well, everything's stale technically. By the time you get it to the time, yes, okay, I get it. But my point being is, like, if something is cached and it can have staleness of like, for what, because you don't know what the caching strategy is behind the scenes. Let's say that thing just is using some time to live expiry of like 5 minutes. We have potentially a 5 minute old cache. Does that matter to the caller? Should the caller know about it? Like, you know what I mean? Saying like, hey, like I have this thing and I've always been using this thing repository and it worked great.
Yep.
And then all of a sudden now I'm getting all these issues because of data consistency, because all of a sudden there's a new implementation that's using a cache and I had no idea when I was writing that code. So it always makes me wonder when people throw in like a new implementation behind that interface that's starting to use a cache. It's like, I don't know how I feel about it.
Yeah, I can give you some examples. So how do I feel about that?
I guess my question is like, are you with me? Like, I guess I'm saying there's context because maybe it matters, maybe it doesn't matter to the caller. But I just generally feel like there's a weirdness to that of like betrayal. You know, I mean, you're betraying that client.
Yeah, I think you're deceiving yourself if you think it doesn't matter. Now, that being said, will you run into issues? I don't know. But
yeah, I think it's context based, but
like I've seen it done. For example, a repository that fetches a current session from the database. Every HTTP request that comes in has to go to the database to get that session's information, which right, user ID and blah, 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 whatever you've decided to have there. And yeah, so you had an alternate implementation of that repository or whatever. So, it's like, okay, now you know that you're not like hitting the database for that request on every HTTP request, like for that user specifically. I've seen it, but yeah, that's just it. Like that, maybe that's an example where it doesn't matter so much because it's cross-cutting. You know what I mean? It's not like application logic specific. But then I have seen it happen in application logic where, yeah, it's like because the developer knew that it was cached, they were trying to hit the cache in a loop, right? Like I mentioned before, because they already know up front, oh, well, I know that like I've already injected that implementation behind the scenes from my BI, and now I'm writing really bad code that looks like it performs okay, but if you remove that cache or whatever, if there's a network issue, or, you'll have weird stuff happen potentially. So yeah, I feel like if you're going to do it, know what you're doing and make it explicit, and that's probably just the safest thing to do.
Yeah.
I think there's a limit to like abstractions. It's like even like thinking about like the single responsibility, that whole idea. It's like now you're caching and you're doing database calls and like you're kind of conflating different things. And I mean, SRP is kind of ambiguous anyways, but it's not a principle I like to be like single responsibility. Don't do that.
Everything is a function ultimately at that point. Like I always say, like everything just becomes, screw it for OO. It's just everything becomes a function at this point. Take it to the extreme.
But I feel like now it's like, it reminds me of web forms, right? Web forms would abstract all the like HTML, all that stuff from you.
HTTP.
Which up front, HTTP. Well, HTML also, right?
Yeah, I guess it could, yeah.
So it's like, I can build applications rapidly, and it's so easy to create a data table, which is like all web forms is good for. And as soon as you need to do anything that's like beyond a basic form, you're starting to have to like jump through hoops and all that, right? So I kind of feel like that abstraction is like, in theory it's nice and on paper it's nice, but then because it's not explicit, I feel like it reminds me very much of like domain-driven design, right? Like one of the like main things is it's like make everything explicit.
Yeah.
Right? This is this thing. It's not like a abstracted whatever, blah, blah, blah. This is the thing that you're trying to deal with in this context. Here's the boundary. I know exactly what I need to do. Well, in theory, again.
Yeah, relatively.
So anyways, I agree. I would rather, there's no reason you can't have an abstraction around your caching, right? It doesn't mean you're going to have like adding like 20 lines of code to every time you need to use your cache. But to have that implicitly done, and like you said, now you lose control over how long you can cache or how you're going to cache it, and like issues around like different priorities when you're caching thing. You might have like, this is a high priority item or this is a low priority item. You have to handle that. How do you handle that now? And I don't like it.
Moral of the story is caching is hard. That's why I say caching ain't easy. Like it's difficult. There's a whole whack load of problems. We hope you enjoyed this episode of the Loosely Coupled Show. If you did, please subscribe for more on software architecture and design.